Hi guys, today we are going to find out what if Newton and Leibniz never invented calculus. You're standing in a 17th century European university, watching brilliant minds scratch their heads over problems that should be solvable. The air buzzes with frustrated energy as mathematicians wrestle with calculating areas under curves using ancient geometric methods. You witness Pierre de Fermat desperately trying to find tangent lines, spending weeks on calculations that should take minutes. Students crowd around dusty chalkboards, watching professors demonstrate laborious geometric proofs that stretch for hours. The mathematical community feels stuck, like trying to build a skyscraper with only hammers and chisels. You probably won't survive the cascading effects of this mathematical vacuum that's about to reshape human civilization. Scholars debate whether certain mathematical problems are even solvable, not realizing they're missing the key. Libraries overflow with geometric treatises that dance around solutions without ever quite reaching them. The Renaissance spirit of discovery begins to dim as mathematical progress hits an invisible wall. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. Drop your location and local time in the comments. I'm curious where in the world you're watching from. Now, sit back and let's dive into today's alternate journey together. The year 1700 approaches, and mathematics remains trapped in ancient Greek methodology. You watch in horror as the Tacoma Bridge of 1742 collapses into the Thames, its designers unable to calculate wind resistance properly. The bridge's geometric analysis seemed sound, but without calculus, engineers couldn't model the complex forces acting on suspension cables. 43 people plunge into the icy water as the mathematical blind spot claims its first major victims. Across Europe, you witness similar engineering catastrophes becoming tragically routine in this calculus-free world. Castle walls crumble under cannon fire because military engineers can't optimize projectile trajectories or structural stress distribution. You observe French artillery officers frantically adjusting cannon angles through trial and error, wasting precious gunpowder and lives. Ship designers struggle with hull curvature, creating vessels that either sink immediately or sail in circles. The great cathedrals being built start showing dangerous cracks as architects lack tools to calculate optimal arch dimensions. You visit construction sites where master builders rely entirely on intuition and prayer, their structures collapsing at alarming rates. Mining operations become death traps as engineers can't calculate proper support beam placement in underground tunnels. Even simple mechanical devices like windmills and water wheels operate at a fraction of their potential efficiency. The engineering profession begins earning a reputation for incompetence, driving talented minds away from practical applications. You realize that without mathematical precision, human ambitions remain dangerously constrained by guesswork and tradition. You find yourself in the Royal Observatory at Greenwich, watching astronomers abandon decades of progress in planetary motion. Without calculus to describe elliptical orbits mathematically, Kepler's laws become mere curiosities rather than universal principles. The brilliant Johannes Kepler's work sits gathering dust as no one can prove why planets move in ellipses. You observe frustrated astronomers returning to Ptolemy's ancient Earth-centered model because it's easier to calculate with basic geometry. Telescopes reveal Jupiter's moons dancing in their orbits, but without mathematical tools, astronomers can't predict their positions. Navigation becomes a nightmare as sailors lose the ability to calculate precise longitude using celestial mechanics. Ship captains rely on dead reckoning and prayer, leading to countless vessels disappearing into the Atlantic's hungry depths. You witness the great Edmund Halley staring helplessly at his comet's path, unable to predict its return. The scientific revolution stalls as natural philosophers can't mathematically describe the clockwork universe they're beginning to glimpse. Universities start teaching geocentric astronomy again because the calculations are simpler for students to understand. You watch as the Catholic Church quietly celebrates this mathematical confusion, seeing it as divine vindication. Galileo's legacy crumbles as his mathematical arguments for heliocentrism become incomprehensible without calculus. The age of precision astronomy never arrives, leaving humanity blind to the mathematical beauty of celestial mechanics. Star charts remain static and unreliable, trapping maritime exploration in a perpetual state of dangerous uncertainty. You step into a bustling 18th century marketplace where merchants fumble with compound interest calculations using primitive arithmetic. Banking remains a chaotic guessing game as financiers can't model risk or predict investment growth accurately. You watch wealthy merchants lose fortunes because they can't calculate the true cost of lending money over time. The concept of economic equilibrium never emerges, leaving markets to swing wildly between boom and devastating bust. Insurance companies collapse regularly as actuaries lack mathematical tools to assess probability and risk distribution. You observe ship owners gambling their entire fortunes on single voyages, unable to calculate portfolio diversification. The Great Amsterdam Stock Exchange becomes a den of pure speculation without mathematical models to guide rational decision-making. Adam Smith's invisible hand remains permanently invisible because economists can't describe market forces mathematically. You witness the first attempted central bank fail spectacularly as governors can't model money supply effects on inflation. International trade stagnates because merchants can't optimize shipping routes or calculate exchange rate fluctuations. The burgeoning capitalist system lurches forward blindly, driven by intuition rather than mathematical understanding. You see brilliant minds like Daniel Bernoulli abandoning economic theory for simpler geometric problems. Without calculus to model marginal utility, the entire field of economics remains trapped in medieval guild thinking. Financial innovation stops dead as bankers can't calculate the risk-reward ratios of new investment instruments. You stand in James Watt's workshop in 1769, watching him struggle to optimize his steam engine design through dangerous trial and error. Without calculus to model thermodynamic efficiency, every improvement becomes a potentially explosive experiment with scalding steam and metal shrapnel. You witness 3 apprentices die in boiler explosions as Watt can't calculate optimal pressure curves or heat transfer rates. The Industrial Revolution lurches forward decades behind schedule, powered more by luck than mathematical precision. Factory owners install machinery based purely on intuition, leading to catastrophic mechanical failures that kill workers regularly. You observe textile mills where spinning jennies operate at dangerously inefficient speeds because no one can optimize rotational mechanics. Coal mines flood repeatedly as engineers can't calculate proper pump capacities or drainage system requirements. The great iron foundries of Birmingham produce inconsistent steel because metallurgists lack tools to model temperature gradients precisely. You watch horrified as an entire Manchester cotton mill burns down when overheated machinery ignites the building's wooden framework. Transportation networks develop haphazardly as railway engineers can't calculate optimal track grades or locomotive power requirements. Steam carriages explode on London streets because inventors can't model the relationship between boiler size, pressure, and safety. Manufacturing remains largely artisanal as mass production techniques require mathematical optimization that simply doesn't exist yet. You realize that without calculus, the promise of mechanized prosperity becomes a nightmare of industrial accidents and inefficiency. You enter Isaac Newton's study at Cambridge, finding him locked in bitter debates with other natural philosophers about the nature of motion. Without calculus to unify his 3 laws mathematically, Newton's insights remain fragmented observations rather than universal principles. You watch as competing theories about gravity multiply wildly, each scholar proposing different mechanisms without mathematical proof. The concept of force becomes hopelessly muddled as physicists can't describe acceleration, velocity, and momentum with precise mathematical relationships. Robert Hooke and Newton's rivalry intensifies because neither can definitively prove their theories about planetary motion or spring mechanics. You observe university physics departments splitting into warring factions, each defending their geometric interpretation of natural phenomena. The beautiful unity of classical mechanics never emerges, leaving physics as a collection of disconnected observations and philosophical arguments. Experiments become purely qualitative since physicists lack tools to model quantitative relationships between variables. You witness Christian Huygens abandoning his pendulum research because he can't calculate the mathematics of harmonic motion. The wave theory of light stagnates as scientists can't describe wavelength, frequency, and amplitude using differential equations. Thermodynamics remains a mystical art as researchers can't mathematically relate temperature, pressure, and volume changes. You realize that without calculus, the scientific revolution fragments into countless competing schools of thought, each equally unprovable. Natural philosophy retreats back toward Aristotelian qualitative reasoning, abandoning the dream of mathematical description of nature. You walk through the corridors of St. Bartholomew's Hospital in London, where physicians practice medicine through dangerous guesswork and medieval superstition. Without calculus to model drug absorption rates, doctors accidentally poison patients with overdoses or fail to provide therapeutic doses. You witness a smallpox outbreak ravaging London because epidemiologists can't calculate infection rates or predict disease spread patterns. Surgical procedures remain brutally primitive, as doctors can't optimize incision angles or calculate blood loss rates during operations. The concept of dosage becomes a lethal lottery, with physicians relying on ancient texts rather than mathematical precision. You observe apothecaries mixing medicines using rough proportions, creating toxic combinations that kill more patients than they cure. Medical research stagnates because scientists can't analyze statistical relationships between treatments and patient outcomes. The circulation of blood remains a mystery as physicians lack tools to calculate flow rates, pressure gradients, and cardiac output. You watch helplessly as plague doctors wearing their distinctive beaked masks spread disease faster than they contain it. Anatomical studies provide detailed descriptions but no quantitative understanding of how body systems function together. Pregnancy becomes a death sentence for many women because doctors can't calculate fetal growth rates or predict delivery complications. The field of pharmacology never develops since researchers can't model how chemicals interact with biological systems mathematically. You realize that without mathematical medicine, healthcare remains trapped in the dark ages while engineering and astronomy advance slowly forward. You travel east to the Imperial Academy in Beijing, where Chinese mathematicians begin rediscovering ancient computational methods forgotten in Europe. Liu Hui's method of calculating areas and volumes, dormant for centuries, suddenly becomes humanity's best hope for mathematical progress. You observe brilliant scholars like Mei Wending adapting traditional Chinese algebraic techniques to solve problems European mathematicians can't touch. Indian mathematicians in Kerala begin sharing their infinite series discoveries, offering glimpses of what Europeans are missing without calculus. The mathematical center of the world slowly shifts eastward as Islamic scholars preserve and expand upon ancient Greek and Persian geometric wisdom. You witness the House of Wisdom in Baghdad experiencing an unexpected renaissance as scholars realize their traditional methods surpass European approaches. Chinese astronomers use their superior computational techniques to create more accurate calendars and predict eclipses with precision that amazes European visitors. The abacus becomes humanity's most sophisticated calculating device, with master operators achieving computational feats that seem almost magical. You discover that ancient Babylonian sexagesimal mathematics provides better tools for certain calculations than European decimal systems. Japanese mathematicians develop wasan, their indigenous mathematical tradition, creating elegant solutions to problems that perplex Western scholars. The Silk Road transforms into a mathematical highway, carrying computational techniques between cultures faster than ever before. You realize that while Europe stagnates mathematically, the rest of the world begins advancing using different but equally powerful mathematical approaches. Traditional mathematical cultures that seemed obsolete suddenly become humanity's cutting-edge computational resources. You fast forward to the 20th century, witnessing a world where computers remain mechanical marvels limited to basic arithmetic operations. Charles Babbage's analytical engine descendants can add and subtract, but complex mathematical modeling remains forever beyond their reach. You observe NASA engineers using rooms full of human computers to calculate rocket trajectories, with frequent calculation errors causing mission failures. The Apollo program never launches because engineers can't solve the three-body problem required for lunar orbital mechanics. Satellites remain science fiction as physicists lack the mathematical tools to calculate orbital decay, gravitational perturbations, and trajectory corrections. You witness the telecommunications revolution stalling because engineers can't model electromagnetic wave propagation or optimize antenna designs. Modern medicine remains primitive as researchers can't create mathematical models for drug interactions, genetic inheritance, or disease progression. The digital revolution never arrives because computer scientists can't develop algorithms requiring continuous mathematics or optimization techniques. You discover that climate science doesn't exist since meteorologists can't model atmospheric dynamics or predict weather patterns mathematically. Economic forecasting becomes impossible as financial analysts lack tools to model complex market behaviors and risk assessments. Nuclear physics remains theoretical curiosity because scientists can't calculate critical mass, decay rates, or chain reaction dynamics. The internet never develops because network engineers can't optimize data routing, bandwidth allocation, or signal processing algorithms. You realize that virtually every modern technological miracle depends on mathematical techniques that simply don't exist in this timeline. Humanity remains technologically trapped in a perpetual early industrial age, unable to break through to true modernity. You stand at the edge of this alternate timeline, contemplating how mathematics shapes the very fabric of human possibility and progress. The absence of calculus creates ripple effects that touch every aspect of civilization, from the bridges we cross to the medicines we take. You realize that mathematical tools aren't just academic abstractions but the invisible foundation upon which modern life is built. Without the language of change and optimization, humanity remains forever locked in a world of static solutions and dangerous approximations. The story reveals how a single mathematical breakthrough can determine whether civilizations soar toward the stars or remain earthbound for centuries. You witness how scientific revolutions require not just brilliant observations, but the mathematical frameworks to make sense of those observations. The tale demonstrates that progress isn't inevitable. It depends on the right ideas emerging at precisely the right historical moments. You observe how mathematical literacy becomes the difference between a world of wonder and a world trapped by its own limitations. The alternate history shows that behind every technological miracle lies an invisible army of equations, derivatives, and integrals working their mathematical magic. You understand now that calculus represents more than computation. It embodies humanity's ability to model, predict, and control the forces shaping our reality. The journey through this timeline reveals how mathematical revolutions quietly determine which futures become possible and which remain forever out of reach. You see that in our world, Newton and Leibniz didn't just invent calculus, they unlocked the mathematical keys to modernity itself. The story concludes with a profound recognition that mathematics forms the invisible architecture supporting every aspect of our technologically advanced civilization. As you step back from this mathematical wasteland, the contrast with our own timeline becomes starkly apparent and deeply humbling. Every smartphone in your pocket, every GPS navigation system, every weather forecast represents centuries of mathematical evolution that almost didn't happen. The bridges you cross without thinking were designed using calculus to ensure they won't collapse under stress or wind. The medicines you take were developed using mathematical models that optimize dosages and predict biological interactions with life-saving precision. Your morning coffee reaches you through global supply chains, optimized by algorithms that would be impossible without calculus-based economics. The electricity powering your home flows through networks designed using mathematical optimization techniques that prevent cascading failures and blackouts. Even the screen displaying these words relies on signal processing mathematics that transforms digital information into coherent visual patterns. You realize that mathematics isn't separate from human experience. It's woven into the invisible fabric that makes modern life possible. The story serves as a reminder that our technological civilization rests on surprisingly fragile mathematical foundations that we often take for granted. Perhaps the most remarkable aspect of our timeline is how mathematical breakthroughs create cascading possibilities that reshape entire civilizations within centuries. Here's something to ponder. If you could travel back and witness the moment when Newton or Leibniz first glimpsed the principles of calculus, what do you think would surprise you most about that mathematical eureka moment?